Alrighty, good afternoon everyone. Welcome to our Lab 6 overview video. In this video, we're going to be talking a little bit about the Lab 6 for the INFR. So let's just get that open and we can take a little grace through it. So this is exercise 6. What we are going to need to do is, it looks like we're going to be using a PC, we're going to need our default gateway, and we're going to need the internet. So the objectives for this is we're going to examine the header fields in a Ethernet frame, as well as we're going to use Wireshark to capture and analyze this information. So I have gone through this a little bit beforehand just to make sure I have all the answers and everything is good to demonstrate. So the first part, we need to review the Ethernet header frame and the descriptions. Okay, that's fine. So it talks about the information about the frame itself. So we have the preamble. In this case here, it describes it as an 8-byte field. The preamble is actually 7 bytes, and there's actually an SFD, which a lot of times is included when you're discussing the preamble, but it's normally the preamble itself is 7 bytes, but there's actually an extra field called the SFD, which is the start frame delimiter. We have our destination address, our source address, which by now hopefully you'll know that those are your MAC address that we're going to be looking for. We have our frame type. So we could see one of 3 possibilities here. One could be the fact that it is a IPv6 frame, or it's an IPv6 frame type. One we could see as an IPv4 frame type, or we can also see that it could be a ARP type. And then we have our data field, which is either basically from 46 to 1500 bytes worth of information. And then we have our FCS, which is our frame check sequence. It's basically a CRC check number that's used to apply to confirm that the actual data itself that was sent actually isn't corrupted at all. So if we look at the data field, one other thing to sort of mention about that is, it mentions here that it's anywhere between 46 and 1500 bytes of information, and you might ask, well, what happens if I have less than 46 bytes of information? Does it not get sent? It still does get sent, it just basically pads the data. That's all that happens. So the field size itself has to be in the range of 46 to 1500 bytes of information. So we continue through, we're going to do a little examination of our PC. So if you're on a PC, you'd use ipconfig/all. I'm going to be doing this between my PC and my Linux virtual machine, so we'll see some things, be slight differences, but we'll keep you all on the same page. The difference being for why we need to use the ipconfig/all is because we want to get the physical address and the default gateway and all that extra stuff. And a lot of times that information isn't given to us when we do just a straight ipconfig. And we'll show the differences between those two. So we're going to need to analyze the Ethernet frames in a Wireshark Capture. So the first thing it looks like we're going to be looking for is an ARP request. We talked about that last week's lab in Lab 5. But we're going to get one of those to happen, and I have that going to be demonstrated through Wireshark with our VMware, as well as I also have our packet tracer that I'm going to be using. So here we got our ARP reply. So yeah, the previous one was ARP request. This is our ARP reply. And then we need to add a screenshot of the ping command to the lab report and a screenshot of the Wireshark. So if I miss something here. So interestingly enough, it doesn't actually tell us we need to run a ping, but obviously we need to run a ping. And it looks like we are pinging default gateway would be my best guess. ARP associated. Yeah, so it looks like we're going to do a ping to our default gateway. That's what's going to be happening there, though it doesn't specifically say that. And then we need to examine the information that's going to be coming up in Wireshark. We'll talk about that in a bit, but one of the things you won't get is you will not get the preamble, and you won't get the FCS. And I can show you how you can emulate that. There's a little option inside of Wireshark, but at the beginning of this I do have that turned off, and I will show you why I have it turned off. Something that I noticed after I turned it on, it kind of makes the rest of it a little bit more difficult to go through and find. What is the contents of the destination address field? Why does the PC send out a broadcast ARP prior to sending the first ping? That's okay. What is the MAC address source field? What is the vendor OU? What is the portion? What portion of the MAC address is the? Yep. Okay. So basically, it's asking us to separate out the two portions: the vendor portion and the actual ID portion. What is the NIC serial number of the source? Interesting. I think that's supposed to say something about the MAC address. So definitely something to inquire about with that particular lab. Add the above table. Yep. Okay. Answer the questions. Not a big deal. Save the output to default route. Yeah. So we're pinging the default gateway, it looks like. In part 2, you use Wireshark to capture local and remote Ethernet frames. You'll examine this. That's fine. So we'll have the IP address of that. That's okay. We're going to start up Wireshark Capture. Observe the data packets. We're going to look for ICMP only. Examine the first echo. So the last one we were looking at ARP, and this one specifically we're looking at the ping portion of it, it looks like. What is the MAC address of the PC's NIC? What is the default gateway's MAC address? Interesting. Seems like some of the common questions back and forth. What type of frame is displayed? Okay, that's fine. The last two lines displayed in the middle section provide the information about the data field of the frame. Notice the data contains the source and destination IP address. What is the source IP address? What is the destination IP address? It seems kind of repetitive in a way, but sure, whatever. Okay, whatever. And then you can click on the middle section to examine how do the last highlighted octet. Okay, that's fine. Click on the next frame in the top section. Examine the echo reply. Notice the source. MAC addresses have been reversed because the same. Yes, because the ping is basically coming back to us. And then we're going to ping Cisco. We're going to see the source and destination. Yeah, so it's actually kind of really similar to last week. The only difference is we're looking into the actual packet a lot more detail. So I'm going to go ahead and check that off to the side. And let me just get back to the beginning of the document. Okay, so first things first, obviously, if you were using your PC, you will want to know what your information is. So if you have a command prompt, we can go ahead and do something like ipconfig. And as an example here, I did it without the /a, and you'll see sort of where the differences are. We see a little bit of information about all the adapters. We actually do see the IP v4 address. We see the default gateway, but we don't see the MAC address. So in order to get that, we would actually need to do an ipconfig/all. And then there we can now see we have our physical address, which should hopefully become pretty apparent since this was something that we talked about last week's lab. We also have my physical adapter for this machine. It's actually not going to be matching the default gateway anymore because of an update. Yeah, so the physical address of this adapter is sort of like a second PC on the same network as my virtual machine. Where in the past, I guess I thought the two were the same, but they're not. They're close. They're both virtual adapters. However, they are one and different if you're trying to ping the default gateway. So that's that. If you're in Linux, we can go ahead and we can do something like an ifconfig. And inside of here, we get our IP address, we get the network information about it, and then we get our actual MAC address, which is right there. If you want to look at the ARP tables, we've already talked about this before, ARP-A. We can see our ARP tables there. Now, this specific table wouldn't actually have the default gateway for the same network as the virtual machine. And the reason being is because I already know how to get outside of my computer. One of the things about the default gateway is that if my machine is uncertain at how to basically get to something, if the IP address or the network is outside of my network, it's going to forward that traffic to the default gateway. So we don't actually need a default gateway myself to talk to the virtual machine. However, the virtual machine will need a default gateway. And one of the things we can do to show that is we can run the IP route command. The IP route command tells us that the default gateway is located at 192.168.157.2. And I've lost my mouse. That's very interesting. I think my battery's dying on my mouse. Okay, anyways. So we have that ARP information there. We have our default gateway here. If you want to display the ARP information, simply by just using the ARP command, we can see that our default gateway here is 05056, which we already know by now that that's a VMware adapter. And it's actually the same series that's used for our DHCP server, which I believe is actually running at 192.168.157.254. But yeah, so we got our MAC address there, which is all right. And if we look at my VMnet 8, you will see the MAC address, physical address is C0008, and you'll see that that doesn't actually match up. So that's good though. So yeah, I reset my adapters and it put everything back to the way it would have been originally. So next up, we're going to examine our ARP entry with Wireshark. So in order to do that, obviously we need to have Wireshark installed. So I have that over here. And before I actually do this next step, I'm actually going to start Wireshark. And it's really important to start this process first, especially if you have a ton of things that are connecting to the network. When your computer receives information from your default gateway, it's going to rebuild this ARP table. So you may not get an ARP reply or a request happening. You might just all of a sudden, have it sort of build up before you even get a chance to do anything. So what you're going to do is you're actually going to go ahead and start this up immediately. So I'm going to select VMnet 8, and now it's turned on. I'm going to slide it off to the side for a second. And then what I'm going to do is I'm actually going to go ahead and I'm going to run the ARP command. I'm going to delete, and because this is Linux, I need to do it this way, ARP-D, and I'm deleting my gateway. And we're going to run that query. And we're waiting for that to go through. Perfect. Okay, that's gone through. If you're on your Windows PC, similarly, if we're in an administrative command prompt, let me just grab that. What you're going to do is you're going to locate the IP address of your default gateway, and then just simply in the admin command prompt, type in the command arp -d space, and then your IP address. So you run that as well. It's then going to go through, and it's going to pretty much produce this information. So now I can do my little arp-a. And we can see all this that's basically filling this out. So what I'm going to do now is I'm going to minimize that, and I'm going to stop my packet capture. So I'm going to bring this over here, and in order to view our ARP, simply just typing in ARP, and we can look at our machine here. So if I recall, its IP address was 157.128, and I deleted the default gateway. Sorry, that's just some of my other work that I was working on. So yeah, so what we have now is we can go ahead quickly and look through here, and actually, because it's layer 2, we need to have the MAC information. 1C07A5. 1C07A5. Perfect. So that's actually when I deleted the information, I believe, or it could have even been... yeah, no, this would have been when I deleted the information. So basically what's happening here is this is our broadcast. We know it's the broadcast, well, one, because Wireshark tells it's the case, but we also know that it's the broadcast because if we look here, we see that our destination is all ones, basically. So we can actually go ahead and expand this, and then we can expand that, and expand that. And then now we can actually look at that sort of bit of information that they were asking about. So we were examining this. So as I mentioned before, the preamble isn't actually going to exist. We know it's 8 bytes of information in total with the SFD. However, that 8 bytes of information is being stripped off physically by our Ethernet hardware. One thing I'll show you an example in Packet Tracer is basically the preamble is just sort of the start of communications. It's 7 bytes of basically a series of ones and zeros to put the two adapters in sync so that way they can start communication process so that they can get as close as possible to avoid any distortion or loss of data. And then we have the SFD field, which basically is the start character that says data is now going to begin. And then afterwards, we then have our MAC address of our destination, which we know from, hopefully, experience, that it's 6 bytes information. So we have our 6 bytes here, and it's in hexadecimal. And then we have our 6 bytes here, which is our hexadecimal for our source. So we got our destination, we have our source address, and then we can see here our frame type, which is 2 bytes of information. So one nice nifty thing is you can actually see it's highlighting the different portions of the hex information down here as we highlight over it. So as we can see here, the first 6 bytes, the destination, we're not seeing that preamble portion. The next 6 bytes information is the source. And then we see the 2 bytes information, which is the type. In this case here, it's because it's an ARP packet. It's being flagged with that. We have the data. We can see the data here is basically being padded out. As we sort of discussed, it has to be 46 bytes of information, or 46 to 1500. So it's basically just padding out the frame with zeros, mainly for the fact that there's nothing inside of there, right? And then if we talk about the FCS, that's not going to exist, as mentioned before, because of the fact that it is stripped out by hardware as well. It's used in the process of ensuring that there's no issues with the actual frame itself, so we're not seeing that portion of it. And then right below it, so we can see here, it's asking inside of here, and we can actually look at the request itself. We can see that it's basically looking for the address 192.168.157.2, which happens to be the default gateway on this specific system. So this system, to get out to the outside internet, has a default gateway, and this is where we would find our default gateway. We would find our sender's IP address here, along with our sender's MAC address, and you can see the target MAC address. We don't know what it is, so it's basically blanked out. And we kind of see that as well in the information. It's basically stating, who has this IP address, which is our default gateway, and it should notify the person who's requesting it, that being myself. And then right afterwards, we can see we get a response. So it's telling us basically the 192.168.157.2 is at, and then it gives it the MAC address for it. So that's E68DDA. So we have that information now, and we know where it's going, so we can look at this reply, and sort of similarly, the only difference is it's reversing. So previously, the source was 1C07A5. Now the destination is 1C07A5 because it was the one who was originally doing a request. So the previous one was a broadcast. This is a unicast. So we see the source is our default gateway. And then if we continue down, we see the type is a is ARP. So it's our it's our 2 bytes of information, and then we continue down farther and we see the information about it. So we see our senders is our MAC address of our default gateway, the IP address, and we see the target MAC address and the target IP address. That's all basically configured in there, and it's being sent back to the person who requested it, that being my machine. So that goes over the table that has to be filled out. What is the significance about the contents of the destination address field? And this was for the request. Well, what is the significance, right? The destination is a broadcast. We don't know where it's going to. And that's also sort of plays into the next question, of why it needs to send it out. So I'm going to leave that off. What is the MAC address of the source in the first frame? So if we look at the broadcast, well, you just pull it up and find out what it is, right? What is the source MAC address? The vendor ID is the first portion of the MAC address. So because it's 6 bytes, we're looking at the first 3 bytes of information. So the MAC address is basically the first 3 bytes. So 00, 0C, 29 is that portion there. What portion of the MAC address is the... I'm going with the fact that it's probably... What portion of the MAC address is the OUI? What is that? Oh, it's just actually a brief off the previous question. So it's just the first half. That's all it is. And then the serial number of the source, I'm presuming that it just means it wants to know the last 3 bytes information. So you're adding that all in there, and then you're going to save this. If you were looking to save this, let me just see something, because this is kind of interesting anyways, but yeah, it still says that it says the name of the file as an ICMP, but it doesn't actually ever tell you at any point in time to ping, but the whole object is it wants you to get an ARP request. So if you really wanted to cover your bases, you could go ahead and ping your default gateway, which is 192.168.168.2, if I recall correctly. Oh, no, it's not. I forgot. This all changed when I reset my adapters. It's 168.157.122. There we go. So that is our default gateway. Throw a couple pings that way. If you're doing this from Windows, you would go and do something like, 192.168.1.1, which is the default gateway for this particular system. So you can go ahead and ping it like that. If you were dealing with, a system that's in an IPv6 network and you're getting that instead, you can just add in the -4 to basically force it over to be IPv4. And when we look at our Wireshark Capture now, obviously we only see ARP here, but we could switch this to ICMP. Let me just filter that. Oh, did I stop it? I did stop it. Let's go ahead and run my ping. And let's go ahead and delete the default gateway so I can get that in there, because I just want to show one extra thing with Wireshark. cool. Got my ping going. Perfect. That goes through fine. So we have our ICMP now here. We have our request and our replies. If we type in ARP, we have our ARP information. If you wanted to capture everything, one cool thing you can do is you just put in brackets ARP and then pipe ICMP, and you can apply a filter like that, and then you'll just get your ICMP and your ARP information there. So that kind of helps filter that stuff out. And then when you want to save the information, when you actually go to basically save the dump, obviously you got to stop it. You go here, you can select save as, and inside of here, do we want to save? Let me just do the test thing. No, that's what I want. I missed the wrong thing. I want to export the specified packets basically. So when I go to do this actual capture, instead of dumping everything, which makes this gigantic file, basically you can have the all packets, and then instead of being captured, which we see it's captured 345, I just want to show off what I've displayed. So I can then just select displayed and then export that little bit there, rather than saving the entire dump of file, which can make these a little bit larger. So that is that part. Yeah, because it looks like, yeah, they're wanting a picture of a ping command. They don't tell you that you need to ping the default gateway, but that's definitely what they're looking for. We've already explained that information. Saved. Yeah, so the next part, we need to basically figure out the default gateway's IP address. Well, we've kind of already done that, and if you forget, simply command prompt ipconfig/all, find your adapter that you're currently working with, look for the default gateway field. If you're on Linux, you know, as you've probably seen already, you do an IF config, you're not getting the default gateway. Instead, you're going to issue the IP route command. And we're going to get that from here. So the default route is, for anything that's outside of my current scope, we're looking at 192.168.157.2. So we're going to go ahead and, yeah, it wants you to stop the capture again and then redo the ping. So that's fine. We can restart the capture. Not a big deal, because we don't actually need the ARP information this time. We just need ICMP. Okay, so I got my capture running on the other edge there, and we're going to go ahead and ping our gateway. So 192.168.157.2. And in Linux, if you don't tell it how many, it's just going to keep going. So I'm going to go ahead and cancel that out. So we got our little capture. And does it want us to save this another time, or do we just got to go again? No, it didn't want us to save it for this part. So I can stop it for now to make this a little bit easier. Okay, so we have gone ahead and we've pinged our default gateway. Stop capturing traffic, that's fine. Examine the first request, perfect. So we're looking at the first one here. I'm going to go ahead and drag this up like that. Actually, move this up a little bit so it's not on the bottom of the screen. And we're going to go ahead and see here. In the packet list, look at the echo, examine the first line of the packet, middle section, display the length of frame, second line. Click on the first frame listed, you should see echo under the highlight it. What is it trying to get us to do? If select the correct interface. Oh, okay. So, Yeah, basically it's saying here that the frame itself is 98 bytes, is basically what they're saying. To look at that, to see that you understand that it's all basically packaged up there. And this specifically tells us like what interface it came in and all that kind of stuff and the ruling that's being applied to it. So we can close that. And we have the information about our layer 2. We have the information about our layer 3. And then we have the information about the ICMP in there. What is the MAC address of the PC's NIC? Yeah, it's the exact same thing we did before. Source is where this is coming from. It's a request, which means it comes from the machine that issued the command. So that would be the MAC address of the PC. The destination is going to be the MAC address of our default gateway, the place we're trying to get to. What type of frame is this? Well, we look here, see? Now instead, this is actually an IPv4 frame. I know some people had reached out prior and they had asked about the whole IPv6 thing. If you had an IPv6 ping, it would actually be ICMP v6 to be able to see it. So if you weren't seeing it before and you were dealing with IPv6, that would be why. So that's our answer to that. What is the source and destination IP address? Well, we can go ahead and close out our frame. And we can look at our Internet Protocol layer. We see here wow, that took me forever to find it, but anyways. We can see here we have our source address. Remembering source being it's a request, it's the person who's asking for the information, so that's going to be the PC. The destination address, that's going to be where we're getting to, the default gateway. You can click on anything, click on the ICMP line in the middle section, exam. Yeah, so that's all that. And then if we close that out, if we click here, it's basically saying, hey, see what part of the frame it's actually highlighting down here. So we can see that it's highlighting this basically bytes 50 through 97. What did the last two highlighted octets spell? Well, we should hopefully know that by now. That basically, we can kind of even see, as an example, if we look at this, we know that each IPv4 address has 4 octets. So we see here, we get 4 blocks of hexadecimal. So if we go to this, we look at the last 2 blocks, because it's asking for the last 2 octets. It spells out 3637. Nothing too complex there. Now looking at the frame reply, yeah, you're going to notice that the 2 swap places, so we can quickly look at this. The source is E68DDA. Destination is 1C07A5. So we see those 2, they're swapping places. So now we can basically answer what is the device and MAC address displayed in the destination now. So we can answer that question now. Now we're going to go do our ping to our destination that's outside of our network. So continue without saving. Going to do a ping www.cisco.com. And in reality, it really doesn't necessarily matter what you're pinging, but for the sake of the lab, it does ask for us to ping Cisco. Okay. So in the first, what is the source and destination? So we got our request. Remembering source is me, the person who's sending out the request, and destination is where it's heading off to. So we see the source is my IP address, if we're looking at that, but it's asking specifically for the MAC address. So we can expand our Ethernet portion. Destination is the default gateway we see, and source is our local adapter. Yeah, it's asking for the IP address next, which was the part I just kind of spilled the beans on. We see the same thing as well. We see our portion of this data. We see our source IP address. We see our destination IP address. So those two things are happening right there. Compare these addresses to what you received in the previous one. Yeah, so all we're doing is just basically saying that, hey, look, these are the same things, basically. Compare. And the address changed, the only IP address. Yeah, so it's kind of something I've discussed before. Is basically when you send off a ping to something outside your local network, it has to get out there, right? And that's why the computer needs to keep track of the MAC address of the default gateway. So what ends up happening is if there's a request for something that's outside of its local network, and you might ask, well, how does it decide what's outside of its local network? It decides that based on its network subnet mask. So we have our network ID and we have the subnet mask that applies to the IP address. And if the destination is outside of that range, it will then forward the package to the default gateway. It's one of the reasons why a misconfigured default gateway or a misconfigured subnet mask can actually cause havoc depending on how drastic out of place it is or how small the actual subnet ranges are. If you just happen to have, half your devices on the same subnet and the other half, because of misconfigured, end up being on a second subnet, then any traffic that's destined between those two could end up going to the default gateway, which would then probably end up with issues because of the fact that it is, it's part of the same network, right? So just watch out for that. And then you got to save this, same thing as well. We have ICMP, you can save your package that way. So pretty straightforward there. And yeah, that's actually the end of the lab. But if you wanted to take a look at the additional bits information, one cool thing you can do inside of Packet Tracer. So I have a little Packet Tracer demonstration here. I've just added a simple PDU. So you click on that, you click on the source, you click on where you want to send the destination to. So you can actually examine your ARP packet as an example. So we click on this, we can see that it's going out. And the out is the layer 2. We have the source MAC address and we have the destination, all Fs. And we have our source IP. And the destination, interestingly enough, looks to be the same. I don't know what it was requesting, to be honest. Source IP, targets. It's rather interesting, but anyways. The main reason why I wanted to actually bring you to this, though, is when you actually look at this, you can see the Ethernet portion, how the preamble is actually there. So we see the 10s, 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 etc. to get to that point. We see our SFD field, so 0 through 8, that's 8 bytes. We then have our destination MAC address, our source MAC address, our type field. And in this case here, it's 0806, which we know from Wireshark being an ARP. We have our variable length data, remembering that it has to be anywhere between 46 and 1500 bytes information. And then we have our FCS at the end of our data there. And similarly, the preamble and the FCS and the SFD actually, those three things won't be visible inside a Wireshark. The FCS, apparently in some cases with certain adapters, with software, you might be able to get that to come up, but typically not going to be there. Now, if you happen to have wanted, I can't remember, perfect, I got an ARP request there. If you wanted your other bit of information, the FCS, you can actually go into Preferences here, and then inside of Preferences, you can actually go into Protocols, Ethernet, and you can assume that the packets have an FCS. However, you'll actually see it kind of breaks them a little bit, so it's not really sure what's going on. But we can actually then see basically the sequence number is being generated based on whatever data is there. So that's kind of what it's doing its best estimate for. And then we can see here instead the FCS is basically coming up, the 34, 35, 37. But let's go to our ARP. Yeah, it just basically breaks the packet and causes weird issues, but there you go. So our check sequence there, we know it's 4 bytes, so we have 4 sets of hexadecimal C0A89D02. So yeah, that's basically the end of this specific activity. But just a reminder that, you know, Packet Tracer does have the ability for you to actually go in here and see the different piece of information. So as an example, you can open up your ICMP and actually see what's going on and the information about it. So you can actually click on this and expand it out and see the different portions of the frame and the data, and where it's basically stored and how much data it takes up. So hopefully you enjoyed today's overview of this activity. I'm sure it will probably help you out a little bit. Take care and enjoy.